the product rule, and combining like terms with exponents. So let's first start with a little bit of practice. This is review, but let's look at this. 5 squared is 5 times 5, and 5 to the 4th power is 5 times itself 4 times. Now when we multiply these two things, 5 squared by 5 to the 4th power, we end up with 5 squared times 5 to the 4th power, and this gives us 5 to the 6th power. When multiplying exponents with the same base, you're going to add the exponents and leave the base alone. So this becomes 5 to the 6th power. Let's do a few examples just to make sure that this concept is solid. So we're going to add the exponents, leave the base alone. This becomes 4 to the 7th power. Same thing here, adding exponents, base stays the same. And our final example, z to the 5th power. I know that it's tempting to multiply those exponents, but don't do it, because remember, this is z to the 3rd power times z squared gives us 5 of them, not 6. So this is z to the 5th. Now, we can clean up expressions by using the product rule. So we're going to rearrange factors to simplify, and I'll show you how. In this example, you'll notice that there's more than one z and there's more than one x. Now that we know how to combine them, we can simplify this. I personally like to do things in alphabetical order, but there's no mathematical requirement for that. They can be in any order you want. So we have 2 x's here. We're going to add those exponents and get x to the 7th power. We have that 1y, so we keep it. And then these 2 z's, add those exponents. Now, isn't that nice and neat? Much cleaner. Let's try another one. Got 1a, a to the 9th power. Now, I've got b squared and b to the 5th power. Because these are all being multiplied, I'm just going to keep those b's together. B squared times b to the 5th is going to give us b to the 7th power. And then finally with the c's, we're going to end up with c to the 7th power. One more example. So let's look at the x's here. We have x and then x to the 5th. This becomes x to the 6th power. There's an assumed 1 there. So taking care of the x's, here's our y. And then again, that z, you assume that it's to the 1st power, and that becomes z to the 5th power. So we've simplified this down to x to the 6th power, y squared, z to the 5th power. Just a quick reminder here, x is really x to the 1st power, same thing as 5. There's an assumed 1 there. It works with any variable, any number. Just like whenever we have x, you can think of that as 1x, right? Alright, one more example here. So I'm going to throw that 1 in just to help us out. So that gives us a to the 5th power, b to the 4th power, c squared. This could also be written b to the 4th power, c squared, a to the 5th power, and there are a couple of other ways you could rearrange that if you want to. Now, combining like terms. We're going to be using the product rule to rearrange some of these terms, but I want to review just a simple concept first. When combining like terms, you only add coefficients. So this becomes 9c, not 9c squared. Leave the letters alone, we're just adding these coefficients. So here, both of these are a squared b So this becomes 6a squared b. Now the commutative property of multiplication allows us to rearrange factors to find like terms. So in this case, I'm going to leave the first term alone, so 2b squared cd, but I'm going to see if I rearrange each of the factors of this term if I can actually find two common terms. So I'm doing these in alphabetical order. Again, you don't have to. It's just what I use that helps me. So I find the B, then the C, and then the D. And look at that. We've got some like terms here, so we can combine them. We end up with 5b squared cd. All right, so now I'm going to rearrange these terms again so that I can compare them more easily and see which ones can be combined. And as you can see, the first and third terms are the same. So those can be combined. Finally now, we can reduce this down to 2x y to the fourth z minus 4x y to the fifth z squared. Stay tuned for practice set solutions.